Hello students, this is Dr. Swati Vitkar. Today I'll be taking a topic Power of Hanoi from Artificial Intelligence. This video is about Tower of Hanoi problem. I am going to show you how to write an algorithm for Tower of Hanoi by taking an example with three disks. The problem is there are three towers given and one of the tower is having a stack of disks in the decreasing order of the sizes from bottom towards top. We have to move all these disks from tower A to tower C, and at any moment of time larger disk should not be kept over a smaller disk. So this will not easy to transfer all the disk. So for help, one more auxiliary tower is given. This one is given, which can use for transferring the disk. There can be any number of disks in this tower. So this take we can take one example. I am taking an example with a single disk. Suppose like this. Suppose there is a single disk given in the tower, then the solution is very easy. Move a disk from tower A to tower C. If there are two disks given, disk 1 and disk 2, then first move will be like this. Then the first move will be move a disk from tower A to tower B using tower C. So we are moving this disk from source to the intermediate tower using the destination tower. As we are not moving into a destination tower, we are moving into an auxiliary tower B. So we have written a statement using C. If two disks are given, then the problem is very small and it's very trivial. And these are now you can see this example, and it is very easy to solve. So suppose there are three disks. So here the problem is larger and becoming complex now. Now here are three disks. So how we can do this? We are saying that move two disks from tower A to tower B. But actually, as per the rule, we have to move one disk at a time. But here we are writing two disks from A to B using C because we have already seen the procedure for moving two disks from one tower to another tower. So this is a recursive function which we are going to use here. So move the two disks from A to B using C. So here C becomes the auxiliary tower, and this is the source and this is the destination. And move a disk from A to C now. So now we are moving this disk to C, that is destination tower, using B. So this the intermediate tower is called as using tower. And then as we already know how to transfer these two disks from source to destination, again we are calling the recursive function here. And that is why we have written move two disks from B to C using A. So always we are using auxiliary tower as using tower. So here we have transferred this two disks from this tower to this tower, and we have already seen how two disks can be moved from one tower to another tower previously. So suppose there are n disks. So in previous example, we have written 2 here. So if 3 disks were there, we have written 2 here. So if there are n disks, we are writing n minus 1 disk from A to B using C. So suppose there are 3 disks, then we are moving 2 disks from A to B using C. Then move a disk from 1, that is A, to C here using B, and move n minus 1 disk from B to C using A. So again two disks are there. So directly we can't move two disks from source to destination. With the help of A tower, we are moving these two disks from this source to this destination. So we have moved all three disks from tower A to tower C, and this is the algorithm for that. Okay, so we are using recursive function here, and see steps are again written here. Move n minus disk from n minus 1 disk from A to B using C. Move A disk from A to C, and move n minus 1 disk from B to C using A. And this is the algorithm for that. So tower of Hanoi n minus 1 ACB, that is tower A to tower B using tower C. And here we are writing printf A to C. So here we are just writing the intermediate position, and then again we are calling the recursive function here, which will move B to C using A, because B was having two disks. So we are moving two disks from B to C using A tower. So this is a recursive function. Now we can trace these three disks like this. So I'm not writing as per the flow of the program, but I'm expanding the procedure here. So if we are passing three disks and there are three towers, 1, 2, and 3. So now A, B, C will be called as 1, 2, and 3. So as per the algorithm ACB, I am writing A is 1, C is 3, and B is 2. Okay, so that is written here. Then printf A and C. So we are printing 1 and 3 here. And then again recursive function BAC, that is 2, 1, 3. And two disks are remaining, that is n minus 1 disks. So initially there were three disks, and now here after expansion it will be used for two disks. So now here we can further expand it, and now one disk is remaining here. And again we are calling the recursive function to solve how to transfer two disks from one tower to another tower. And here we are printing the intermediate results in between. And as only one tower is remaining, after one tower, the disk will become 0. And that is why the loop terminates here. After, uh, after n minus 1, 1 minus 1 becomes 0. So it terminates here, and these are the intermediate steps, that is printf, which is rewritten here like this: 1, 2, 3, 4, 5, 6. So we can trace the same thing by using the disk now. So we have written as 1, 2, 3. So here we are moving one disk from 1 to tower 3. Okay, the second step is 1 to 2. So here we are moving this disk from 1 to 2. See here, 1 to 2. The third step is 3 to 2. So here we are again moving 3 to 2 here. 3 to 2. Then 1 to 3. So this will be moved from tower 1 to tower 3 like this. Then 2 to 3. So 2 to 1. This is 2 to 1. So we are moving 2 to 1 like this. 2 to 1. And then 2 to 3 here. 2 to 3. And then 1 to 3. So this is how we have transferred all disk from tower 1 to tower 3, and this is done. So the application, you can go through the application that it uses stacks and recursive function, and for backup rotation scheme is used. The backup rotation scheme is a system for managing your backup storage media. That is, you can use any storage media for that, and used by neuropsychologists trying to evaluate frontal lobe defects, deficits. And these are the references. Thank you very much for your patient listening. Thanks.